in this video, we'll be discussing the concept of origin shifting the origin. First of all, we will be discussing this with an example. If you want, you can go with the one dimension also. Now, I will be using an example in the Cartesian plane. Now, we will be having xy plane over here. So, this is our x-axis and this will be our y-axis respectively. Now, this is our origin. That's a normal. Now, I will be taking a random point 1, 2, 3, 4, 5, 1, 2, 3, 4. Now, the thing is, I will be taking a random point with the old coordinate system. I will be taking a point, for example, I will be taking x comma y, ordered pair x comma y will be 5 comma 4. So, what will be 5 comma 4? This 5 and y value will be 4. And this 5 comma 4 of this point will be, this 5 comma 4 will be based on the old coordinate system, that will be x comma y. Now, in next case, I will be fixing one of a random point. For example, here I will be taking 3 comma 1 as my new origin. So, this is our new origin. I will be taking 3 comma 1 as the new origin. That means I will be shifting that origin from 0 0 to a new point 3 comma 1. So, the thing is, new origin I am calling new origin as h comma k. I will be shifting the origin from 0 0 to a new point 0 h comma k. That will be 3 comma 1. That means I can have another set of coordinates axis. One is the y and x respectively. So, I will be calling this x coordinate as capital X and y coordinate as capital Y. Now, if you closely observe, with respect to new coordinate system, this will be 1 and this will be 2. That means this x coordinate will be 2 and this will be 1, 2 and 3. So, with respect to new coordinate system, that is, you can observe the red lines. So, it will be 2 comma 3 will be your new coordinate, which will be capital X comma capital Y. Now, we need to form the relation between these two, that is C1. With respect to new coordinate, capital X comma Y is the new coordinate, which is equal to 2 comma 3. 2 comma 3 you can see from here, 2 comma 3. Now, if xy is the coordinate with respect to 0 0 as the origin, then if you if you shift the origin from 0 0 to a new point hk, then the new coordinates will be of the form capital X comma capital Y. Now, the relation is capital X equal to x minus smallest minus h, and similarly capital Y will be equal to y minus k. That is, here this x coordinate is, see this one, x equal to smallest minus h, where small x is the coordinate of the x coordinate of the point when 0 0 was the origin, that is 5, minus the x coordinate of the origin, the new origin is 3. That means you will get 2. Similarly, the y coordinate of the new origin will be y minus k. That will be equal to y coordinate, earlier original y value was 4 and the y coordinate of the new origin is 1. 4 minus 1, which is equal to 3. That means the new coordinate will be 2 comma 3, that is x comma y will be x minus h and comma y minus k. So, this concept of origin shifting can be used to solve questions in complex numbers or other chapters. You can use it. That is, suppose you want to evaluate something for a geometry which is somewhere here. Instead of that, it will be always equal. For example, suppose there is 4 points lie in the circle. Now, if you want to solve it, everything is towards one quadrant itself, right? Now, because of the symmetricity, if you find a new coordinate axis in between, if you find one value, the same symmetricity works for other values. So, automatically, if there is a point here, multiplying 4, you will get the 4 other points. That means, Suppose this is a scenario of a circle where you need to get 8 points which can satisfy some specific condition. Now instead of this, if you shift the origin to that point and you observe that 2 points, a pair of point lie on the first quadrant, so that automatically another pair of points will be lying here, 2 points will be lying here, another pair will be here, and another pair will be here. Instead of finding all 4 pairs separately, you can make use the symmetricity of the geometry. That's the basic advantage if you know how to use the concept of origin shifting.